How's it going, everybody? In this video, we're going to pick up right where we left off in the previous video when we introduced the SD-WAN series. In this video, we're going to be focusing on understanding the aspects of the solution. So what are the different controllers? What are the different devices that we're going to be working with? What do they do? And why are certificates needed? We'll talk about that because I actually was a little disappointed that I needed to go through and set up a certificate authority and go through all that process. But you know what? If you don't ever learn it, you'll never know it. So thanks, vTLA. So let's go ahead and dive into the details of what's actually happening here. And my pen tool disappeared. Wherever it decided to go. Anyway. Alright, so what I'm going to do is grab this out and we're going to discuss some of the different devices. So let's first start off with the controllers. So we have vManage, okay? Actually, before I do that, let's talk about the difference between a traditional network device and an SD-WAN device. So a traditional device, like this router right here, for example. Where does all the operations on the router exist? Well, the majority of things are going to be happening with the CPU, which means that your control plane, your management plane, and your data plane are all going to exist on the same device, right? Everything is going to be right here. We can all pretty much agree on that, I'm sure. And if you didn't know that already, well, there you go. So in this particular example, if this router needs to do anything to, if you need to affect how the router works, then for example, the administrator would need to connect to the management plane through either a console connection or through some sort of telnet or SSH connection, and then make whatever changes it needs to. This will get pushed down to the control plane, which will affect how the device will begin to operate. And then the control plane, depending on what's being done, will then take that information and then push it to affect the data plane, right? So that's basically how that process comes into play. In an SD-WAN solution, the way that this works is that the data plane exists here on the V edges, right? But the management plane and the control plane exist elsewhere. So the management plane is handled by the vManage, and the control plane is handled via the vSmart. What ends up happening is these devices, being a centralized operation, it takes the control plane and management plane off of the device itself. So right now, no more management plane or control plane here. They're both gone, right? They're moved elsewhere. Now that's a good idea, and the reason why that's a good idea is because now you're not having to configure the same thing on multiple devices. I've been in several situations where I have a mass deployment that I've got to go do, where friends of mine that work in the automation space, they work with Ansible or Python, and they're creating playbooks in order to configure the same thing multiple times on multiple devices, and so they can just run it and automate it and just have the config pushed out to the device. That works, and it works well, right? I haven't really studied automation at all, really, so at some point in the future, I'm sure I'll have to pick up a little bit of Python, a little bit of Ansible. But the cool thing about this solution is I can do things through the vManage, which manages all the devices. And I can also do things through vSmart, which controls all the devices. So how do they actually do that? Let's talk about that a little bit more. What ends up happening is when you bring the vManage online, it's going to, when it's fully operational, I should say, it's going to form connections to each one of the whoops, that's not going to one. Each one of the V edges, right? And it does this because it needs to control how the operations are going to be handled, right? So it logs in, it pushes the config templates down to the V edges. It does all of that type of stuff. So this is absolutely 100% your management plane, right? This is, you log into vManage, you configure templates, you configure policies, all that type of stuff happens here. And then from there, it gets pushed out to other devices. Now, the control plane is a little bit different. Let's switch colors over to orange. The control plane is a little bit different. For those of you that are new to vTLA or new to SD-WAN, viptela is the only solution that I'm aware of, and if you know of it, know differently, please comment in the comment section below. viptela is the only solution that I know of that actually has a dedicated management or control plane protocol that's used to control how the WAN edges are going to work. Where all the other solutions that I'm aware of, they might have a cloud component or they might have a controller component that they use, but none of them are really protocol driven, right? You might have some IPsec VPN set up, but there's really no control that's a dedicated control plane protocol that's used to take the information that's configured on the controller and push that down to the WAN edges. Now, let's not confuse taking specific, like an API, like netconf, for example, and pushing a netconf rule or doing an API push from the management device to the data plane device, so the vEdge, for example. That's not what I'm referring to. viptela is the only solution that I'm aware of that has a dedicated protocol that's used for communication between the controllers and between the edges, and that's OMP. Stands for the Overlay Management Protocol. OMP was purpose-built by some folks that came from Cisco. They left Cisco, became viptela, and then eventually were reacquired by Cisco a number of years later. I think they were on their own for 2 years, went through a couple of fundraising examples, and then boom, they eventually got reintegrated. So I have my own personal opinions on how Cisco has done the SD-WAN thing. I'll keep those to myself because none of them are relevant anymore. But OMP, what ends up happening with OMP, let me go ahead and write this up just a little bit and jump out of the way real quick. OMP is actually formed from the vSmart to all the vEdges. So there's an OMP peering here, there's an OMP peering here, there's an OMP peering here, here, and here, respectively. And the vSmart is what controls how the devices will do things. So let's also keep in mind that control plane is one thing and data plane is another. Control plane is going to dictate how the device is actually going to forward traffic. So no different than if you had a couple of routers hanging out here, right? And you have a link between them. Let's say you have another router over here, and there's a LAN segment sitting on each end of these devices. Well, if you're running EIGRP here, here, and here between these devices, this guy right here, let's say this is 2, this is 1. This is 1, 2, and 3 respectively. What's going to happen is on router 1, you're going to learn about 2's routes, and router 2 is going to learn about 1's routes, right? Through just normal EIGRP propagation. That's all well and great. Now, and if I need to switch directions and how I'm going to go about doing that, I need to, let's say for instance, I jack the delay up on this interface by 10,000. And now this path becomes the most preferred, right? So I'm going to go send my traffic this way to reach the destination versus this way to reach the destination, okay? Now, when you set up your dynamic routing and you type your network statements in and get the EIGRP adjacencies up and all that type of stuff, there's a peering, right? That peering, you're sending information back and forth between you and myself. So for example, if you and I were to meet and I was to walk up and shake your hand, we're physically touching, right? Well, in order for that to happen, there needs to be a logical connection between the two in order for the communication to happen. So in this case here, routers 1, 2, and 3 all detect each other because they're sending hellos out and they're like discovering other EIGRP neighbors. Router 2 sees that R1's trying to find it. R2 responds to the hello, says, yeah, I'm over here. Or if you walk into a large room, or like you walk into a conference room and you don't see anybody at first, but you walk in and say hello, and somebody pops out of a room and goes, oh, hey, how you doing? You know, such stuff like that does happen, where in situations like that, then it's like, oh, you discovered somebody, right? And they respond to your hello, and you're like, oh, I'm here for the whatever, you know, I'm here to do that. And that person's like, oh, yeah, I've been expecting you. You know, that type of stuff does happen. So that's basically how dynamic routing protocols work, right? And then you talk to each other, you exchange information, and voila, the propagation happens. Now, how that correlates here is the control plane. So whenever I tell you what I know and you tell me what you know, then I have to do something with that. Once the routing exchange has happened, then I need to take that routing information. So basically, I know how to reach your networks that you advertise to me by pointing myself to you. So if anybody behind me or any of my users want to talk to any of your users, they must go through me, which means they're in the data plane, right? This is data plane communication. And I know how to reach you because you and I know each other exist. You and I have communicated with each other's routes, so we know who's got what and how to get there. We use that information to say, okay, user A wants to talk to user B, and user A sits behind router 1, user B sits behind router 2. In order for that to happen, I need to point user A traffic to router 2 in order to reach user B, if that makes sense. So dynamic routing protocols, traditionally, that's how they work. OMP is pretty much the same thing. You take OMP and its job is to affect how traffic flowing through the vEdges is going to be affected. So when you think control plane, think OMP route propagation. You know, what am I going to do where, how am I going to do that type of stuff, all that good stuff. Now the data plane is another separate type of thing. There are some data plane operations, like I can use quality of service to affect something. So I can say traffic for voice and video and maybe web and some other applications are given precedence over other types of traffic, and therefore they're queued differently and then sent out ahead of other traffic. I can do that. If I want to filter traffic, like for example, if I want to filter traffic in the data plane, I want to prevent Rob from being able to telnet from, in this case here, R15 here. I don't want him to be able to telnet to R14 over here. Well, guess what? I can create an access list to push that. I create the access list in vManage, and then I push that down to the vEdges that need to get it, and then once they get it, then we can go forward and get everything else squared away. That means that the access list would then get pushed, and I can tie the ACL to a template, the way it gets pushed down to the vEdge specifically, and then applies the ACL. It's kind of a weird way to do things, but that's basically how that goes. In situations like that, that's what they refer to as a localized policy, is you have to create it on vManage. You have to create the policy first, right? And you have to create the ACL. And then you take the policy itself, and that calls the ACL, and then you push that information down to the vEdge. And then you go to a template that would apply that ACL to an interface. And then you update that, you push the template down to the vEdge that's going to affect the interface and the template and all that type of stuff, and applies that ACL to the interface. It's actually kind of cool how it works. You're going to find that the centralized control policies and centralized data policies are a little easier to work with because you basically just create whatever you need to create and then push it, and then you're not worried about it. But anything that's local, which means you have to push something from the management device or the controllers from vManage, you have to push that down to the actual vEdge and then circle back, go to the template, update the template, then push the template updates down to the vEdge so you can affect the data plane. So pretty cool stuff. Now, with all that being said, once you have that, the control plane is what affects how the vEdge will actually do its job and send traffic. So for example, if I'm here on router 15 and I want to talk directly to router 13, what's going to end up happening is there's actually going to be an IPsec tunnel set up between vEdge 4 and vEdge 3. And I'm not going to have to do anything. If I want to send the traffic, guess what? I send it over the VPN tunnel, it lands here, and I'm good to go. But let's say, for instance, I don't want traffic from R15 to reach router 13 directly. Let's say I want it to go through the hub. Well, guess what? I can change how the routing forwarding will work on the vEdge to point to the vEdge and up here at the HQ, and then redirect the traffic back down there. This is what they refer to as hub and spoke. So we can do that. Now, the reality of it is, when you set these devices up, out of the gate, everybody forms a full mesh of IPsec tunnels to everybody else, right? This happens out of the gate. You don't have to do a thing about it, right? And everybody becomes happy, 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 joy, joy, right there, right? No, that's already there. Let's see, what else am I missing? I think that's it. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Oh, right here. So on and so forth. So now we have a full mesh of tunnels, right? Now I can affect how I send traffic, even though I might have a IPsec VPN sitting between two V edges for spoke-to-spoke communication. That doesn't mean I have to go through and push the details or push the traffic over that IPsec VPN to the V edge that connects to the destination I want to go to. I can say, you know what, you're not allowed to do that. You need to go through the hub first and then go to the spoke. By default, that's not even how it works. If you do a hub and spoke, you mean you have communication from hub to spoke and from spoke to hub. You don't have any spoke to spoke communication. You have to do some additional route advertisements in order to make that happen. But at the end of the day, it gets the job done. So that's basically how that comes into play. Now, that's the VPN aspect of it. Now, let's talk a little bit about some of the other things that you see in here. You might see where it says vManaged here. You might see these IP addresses sitting here. You might be like, okay, why is that? Well, this means that I'm going to manage this V edge, this V edge, this V edge, and this V edge all from vManage, where this device right here will be controlled through the CLI, which means I'm going to have to type in all the commands at the command line, because guess what, ladies and gentlemen, you can 100% do that at all times. Now, it's a one or the other type of deal. So if you're in a situation where you want to run vManage all the time, and you're like, you know, I'm not really feeling this vManage thing today, I want to go to CLI, you can actually detach a device from a device template and then convert it back over to CLI, but then you remove all the configuration. And then you have to go configure it, and that's just a big hassle. But it's not the reason, that's not the direction Viptela and Cisco and the SD-WAN world in general want you to go. They want you to use all of the automation capabilities and the controller capability to deploy the solution in order to make it work the way we need it to. Now, with that being said, you have these situations in play. They do work. You need to take them into consideration for what they are. Now, there's a couple of things we need to pay attention to before we start diving into any of the real big bad information world. So there's this thing known as a system IP. You have a site ID. So I'll just put a SID here. You have the organization, stuff like that. So the system IP, think of this like a loopback address or a router ID. That's basically what it is. It's nothing more than that. It's not something that needs to be routable, right? You don't have to be able to communicate from system IP to system IP. As a matter of fact, you don't do that out of the gate. So what will end up happening is you configure each device initially with the system configuration, which is going to include your system IP address, your site ID. Oh, I forgot to mention the vBond. So I'll put vBond over here. You configure it with a vBond so it knows where to point and all that type of stuff. So once you get your minimum configuration in place, then you're in good shape, because then you can start communicating back and forth with the other devices and you're good to go. Now, when you get this all up and running, one of the things you have to do is on the CA here, is the CA is going to basically be a router acting as a certificate authority. And the certificate authority is going to generate certificates. It's going to generate a couple different types of certificates. The first one that's going to deliver is going to be the root certificate, and the other one is going to be the identity. You might say, well, why do I need to worry about root certificates and identity certificates? Well, out of the gate, the reason why you need to do that is because that's how all of these devices are going to authenticate each other, is through the use of certificates, right? It's a more secure way of handling things other than the pre-shared key you would with a site-to-site VPN, for example. What ends up happening is this root certificate that is generated by the certificate authority is actually imported by all these devices, right? It's imported on all the devices, and once it's imported, then it can be used to build what they call the root cert chain that is going to basically be used to help build out the entire authentication mechanism. So the root cert chain is going to be a combination of the root certificate plus the identity certificate and root identity cert. And what that's basically going to do is once it's created and once it's working, then you'll have a known good entity in the network that can authenticate different devices. So when I create the root certificate and on the CA, when I go to set that up, what ends up happening is once that's imported, they all have the same information, right? So everyone's going to know who the root certificate is. So when they go to take an identity certificate that is being presented to them by another device, and that identity certificate was signed by this root certificate, by the root CA, they're going to compare the root CA to the root certificate, and they're going to be like, oh, it's the same box. It's no different than, for example, if you open up google.com, right? Google.com has a certificate mapped to that particular web server, and that web server, or I should say that certificate, is valid for a period of time. Well, let's say a year. So right now it's the middle of September 2020. If that root certificate, or I'm sorry, if that certificate was granted to that particular web server on, say, September 1st, 2020, it would be a valid certificate because I'm after the beginning date. But if it was September 13, 2021, that certificate would not be valid, right? Because you're outside of your duration. Basically what ends up happening is if I'm a root CA and I need to be able to authenticate a device on the network, I need to provide that root certificate to that device that's doing the authentication piece. So he's basically the authenticator. If that root certificate is not assigned to everybody, they're going to look at it and be like, yeah, I don't trust it. Because if the certificate is too old or isn't recognized or you don't trust who the CA is, that's a bad thing. So that's why we install the certificate, the root certificate on all the vEdge devices and all the controllers, so that when a identity certificate is generated and then taken to the CA, it's then signed by the CA, and you get an identity certificate kickback. I mean, in other words, it's granted to you. You import that information onto the device that you're working on, and then when that information is exchanged between two other devices, they're going to compare notes and go, okay, well, this guy was signed by this root CA, this guy was signed by this root CA. Oh, they're the same box. We're good to go. They're going to trust each other. So we're going to go through that process and set that up. Now, what ends up happening is these devices will all form a Dtls tunnel to each other, and that's going to be how they form their connections. And then after that, then the management plane and the control plane will come on board. The vEdges will be pointed to the vBond, right? The vBond, they'll be pointed to the vBond, which is the authenticator. So let's talk about that for a few minutes. We'll start with the vBond. The vBond is your authenticator, and it's also your orchestrator. So if we were going to do plug and play or ZTP, zero touch provisioning, the vBond would be that mechanism to pull that off for us. So you point yourself to the vBond. The vBond has all the information. Once you go through the propagation process, so you install the root certificate, the root cert is installed, then you generate the CSR, certificate signing request. The CSR is going to have some information about the vEdge that is going to be sent to the CA. The CA is going to go ahead and grant a certificate. Then we take that information, we paste it into the vEdge, and once it's good to go, then the vEdge will be able to generate what they call the certificate serial number. The certificate serial number output, which is a combination of the chassis number and the serial number. This information is actually pasted into the vManage and the vBond. Once that happens, then that device now comes on board into the SD-WAN fabric. Then we do a fancy little command that we push that stuff down to vSmart, and then vSmart then opens up an OMP peering to that particular vEdge, and that's when the control plane begins. That's also going to form a control connection to vManage and a control connection to vBond, as well as a control connection to vSmart. But that's part of this whole process. And after all that stuff is done, that's really when you can start letting the rubber really hit the road and how all that type of stuff comes into play. So that's basically where we are at. I'm already 25 minutes in explaining how this process works and all that type of stuff. So I'm going to stop this video. This will be more of the how SD-WAN works on the back end from the theory and the processes. In the next video, we'll go ahead and get the CA set up, and then we'll bring on all the controllers. And I'll walk you through step by step on how that process works. So with that being said, ladies and gentlemen, thanks so much for stopping by and hanging out with me, and I'll catch all of you in the next video.